Assalamu alaikum, this is Dr. Ahmad Al Faris. Today we are going to answer past paper, February-March 2021, paper 4 variant 2, okay? Now this paper, okay, it's a unique paper, okay? It has a lot of new ideas, okay? But it's not that hard, it's easy. Now we are going to answer these questions with explanations. If you have any question, you can send me on the chat directly, okay? Or you can raise your hand. First question. The figure below, the figure shows a piece of glass, okay, of thickness 2 centimeter and area 0.015 meters square. The density of glass, it's what? 2.6 times 10⁻³ kilogram per cubic meter. Okay, they give us the thickness, okay, in centimeter, that means 0.02 meter, and they give us the area, okay, which is 0.15, and they give us the density. Calculate the weight of this piece of glass, okay? Now we know that weight equal mass multiplied by gravity acceleration, and the gravity acceleration is 10, but we don't know the mass. So we have to first find the mass, and we know that density equal mass over volume. So by doing cross multiplication, now we know that mass equal density multiplied by volume, and the density, which is 2.6 times 10⁻³, okay, multiplied by the volume, which is the thickness multiplied by the area, okay, and the thickness is 0.02 multiplied by the area, which is 0.15. Whatever the answer it is, I will substitute it here instead of the mass, and I'll multiply it by 10, and what we will get finally, 78 in Newton. Two significant figures, 78 Newton. This is the weight of this glass block. Okay, yes, density equal mass over volume. Yes, thank you. Yes, correct, Muhammad. This is part A of this question. Part B, what do they ask? A piece of glass, this piece of glass, okay, in this figure is used to a vertical viewing window of an aquarium, okay, at the atmospheric pressure from outside is 1 times 10⁵ Pascal, and the average pressure from inside the aquarium is what? Is 1.3 times 10⁵ Pascal. Now this is the window, okay? And this is the aquarium from inside here, for example, okay? Now they said that from outside there is a pressure of atmosphere, and from inside we have a pressure from the atmosphere plus what? The pressure of the water, okay? Which is what? 1.3 times 10⁵. What they ask now? Calculate the resultant force, okay, acting on the window due to these pressures, okay, and state the direction that acts on it. Now we know that the pressure from inside, because it's greater than the pressure outside, so that means it will be outward. The direction, it will be outward. Now, how much is this force? We need to know that the pressure, exactly, thank you. Pressure equal force over area. And now we are not talking about normal pressure, we are talking about change in pressure from outside and inside. So we subtract these values, okay, to find how much is the force. So by doing cross multiplication, the force, which is equal to the change in the pressure multiplied by the area, okay, and the pressure here, it's 1.3 minus 1.0, all multiplied by 10⁵, multiplied by the area, okay, which is from the previous part, which is 0.015, okay, and we will get the answer. It will be 4.5 times 10⁻³ watt Newton, 4,500 Newton. 4 marks on this question. To subtract, to find the difference in pressure, yes, it's 1 mark. To multiply by the area, it's another mark. And to get the answer with direction outward is another 1 mark, 1 mark, so 4 marks. Yes, it's easy, 4 marks. Yes, Muhammad, thank you. Let's move on to part C. In part C here, what do we have? The figure shows the vacuum pump connected to the top of vertical tube, okay, with a lowered into immersed in the tank of liquid. The pump reduce the pressure above the column to be 0, like it's a barometer. So we have to reduce the pressure here to zero like the vacuum above the barometer. Okay, it's similar to it, but it's not exactly the same. The pressure at the point X here, okay, that caused only by the liquid above it, because here the pressure is zero, as they tell us, is 9.6 times 10 of 4 Pascal. Calculate the density. Now we know that pressure of any liquid equal density times gravity times height. So we will rearrange the equation to make it density equal pressure divided by what? Gravity times height. So the pressure, which is 9.6 times 10 to the power of 4, exactly. Yes, it's first question. What do you mean? Sir, can you please explain again? You didn't understand what? Yes, Sandy. Now, what they ask, look here, calculate the resultant force acting on the window due to this pressure. We have pressure from outside and from pressure from inside the aquarium. Okay, this is the window of aquarium. Okay, so there is a pressure from atmosphere from outside and the pressure from the liquid or the water from inside. The difference in pressure causes a force where outward, and this force, okay, by knowing that pressure equal force over area, so pressure, so we do cross multiplication, force equal pressure times area. I'm asking about changing pressure here from inside minus the outside. Okay. Ah, you are welcome, no problem. So the same thing here, multiply the density equal pressure divided by gravity acceleration multiplied by the height. And the height here is what? Is 12 meters. And by using the calculator, two significant figures, it would be 800 watt, the density kilogram per cubic watt meter. Actually easy 10 marks, not only 4 marks. What do you think? Is it okay? Yes. Yeah, it's low density. That's why the height is too long. It's 12 meters. Yes. Okay. Let's move on to question number 2. In question number 2, what do they ask? They ask about the moment, as you can see. Okay. State what is meant by the moment of the force about a point. It's the turning effect. The turning effect of this force by or around or about a pivot, okay, the turning effect, yes, about a pivot. That's part AI. Part double I, what do they ask? The figure shows what? Always forget that definition. Why? It's easy. Okay. The figure shows a large crane, okay, on a construction site, lifting a block of mass 14,000 kilograms. Okay, we have counterweight. We have a block here, which is 20 meters from the center of it, and there's a campaign here. Okay, calculate the moment about A. Okay, caused by the 12,000 block. Okay, now we know that the weight causes the force. Okay. And it acts in the direction of what? Of clockwise about A, like in this direction, about what? About A, okay? So moment of the block is equal the weight of the block multiplied by the distance, force multiplied by distance, and the weight of the block is 14,000 multiplied by 10, okay, the mass times gravity, okay? Okay, multiplied by what? The distance, which is what? 20 meters, and our answer, it would be 2.8 times 10 to the power of 6 Newton dot meter. Okay, good. Any question here? Okay, someone get inside our class with the name of iPhone. If you please change your name, get out and return back by your name, Osmat. Okay, I'm asking you. Thank you. Yes, thank you. Okay. So the weight, which is the mass times gravity, okay, which is the mass of the block times the gravity acceleration multiplied by the distance. This is the answer. You got this question in your mock? Okay. Tamam. And you did it correct, right? I'm sure. Okay. Part B. Speed is a scalar quantity and velocity is a vector quantity. Okay. They didn't ask about the direction. So it has direction, yes, clockwise, but they didn't ask about it. So speed is a scalar and velocity is a vector. State the difference between a scalar and vector quantity. Scalar has magnitude only. Yes, thank you. Thank you. Correct answer. But quantity, but vector, okay, has magnitude with direction. With direction. Two easy marks, right? Yes. Thank you, Marwan. Thank you, Muhammad. And thank you, other Muhammad. We have two Muhammads here. Yes. Okay. Next. Write down one other scalar quantity and one other vector quantity. Who can give me a scalar quantity? Yes, thank you, Muhammad. Temperature, another scalar quantity. Mass, bravo. Speed, exactly, Ibrahim. What else, Marwan? Okay. What about the rest of you? You are a lot. Okay. Yes, energy. Yes. Type. Anything? No, speed. Speed is correct. Speed doesn't have direction. Velocity has direction. So this they said here, but you can't mention speed. Yes, because they mention here speed and they mention what? Velocity. You can't mention speed and velocity. Okay. So moment, yeah, exactly. So you can write here mass, temperature, time, whatever. Okay. Vector quantity, moment, weight, force, acceleration, momentum. Bravo, Alaikum. Yes, thank you. Correct. Excellent. Okay. So sound waves, I can't I can't take a chance to write an answer like this. Okay. Fine. No, I will not write sound waves. In neither, in both. Okay. Fine. Let's move on to part C. In part C, what do they ask? Figure 2.2 shows two forces act on an object. Okay. Draw a scale diagram to determine the resultant force acting on the object. State the scale you use. Okay. So what is the scale that I'm going to use? Okay. In this, for this situation, I'm going to use what? This drawing here. Okay. What do we have here? We have 20 centimeter here, 30 centimeter here. So I will write that I'm going to use a scale for each 1 centimeter. It's equal to, oh, what's happening here? Okay, for each 1 centimeter, it will be, for example, 5 Newton. That means this will be 6 centimeter and this will be 4 what centimeter. And I'm going to draw what the scale according to this. Okay, so what do I will use? I will use my protractor. Okay, I will use my protractor and I'll put it, okay, on 60 degrees. This is 60 degrees. And I'll rotate it, okay, to make it like this, vertical line. Like this, because my two forces, one force is downwards and one force to the right down. Okay, then I'll try to start the drawing. Okay, like this. Okay, now this drawing I'll repeat them by what? By a scale, and it will be as I told you here. Okay, so if I put my ruler, something like this. Okay, and I'll make this 6 centimeter. Exactly. Okay, this is 6 centimeter until this point. Okay, I'll change the color to draw the other force, which is what? which is 4 centimeter from here to here. Okay. Then what I will do, I will use my compass. Okay. And I will draw it this way, like this. Oh, let me. Okay. Like this, I will open the protractor. To make it 6 centimeter. Hold on. Exactly 6 centimeter. Then I'll move it to the other side, to the 4 centimeter. Then I'll draw my arc. What's happening here? Okay, there's something wrong in my protractor. Okay, in my compass, sorry. I will use my ruler to draw what? 4 centimeter downwards with a red color. Okay, like this. This is 4 centimeter. Now my answer, it will be what? It will be the introduction. It will be the intersection between what? Between what I draw until here. Okay, this is my answer until this point where they intersect. Okay, I will use my ruler and measure how many centimeter it is. Okay, like this. As you can see, it's approximately how much? 8 point. It's 8 point what? Yes, 8 point approximately 5 or 6. Yes, 8.6. That means I'll multiply it by 5 as we learn here. Okay, and I will get my answer. And according, okay, hold on. Okay, so the answer, it will be approximately how much? How much 8.6 times 5? By using calculator, my scale is 1 centimeter equal 5 Newton. So 8.6 multiplied by 5. So my force, it will be 43 Newton. Finally, they ask about the direction of the resultant force due to the 20 Newton. So I will turn back here. I will use my what? I'll use my protractor and measure how much is the angle with the 20 what degrees. It will be approximately how much? It will be approximately, not approximately, exactly 37 degrees. No problem, Abdurrahman, no problem. So the answer, it will be 37 degrees. That's how we can get 4 easy marks by drawing. Okay, it took a longer time because I had problem with using the tools. But you have to label that this force is the 30 Newton, and this force is the 20 Newton. Okay, so this force is the 30 Newton, and this force is the 20 Newton, and this is the resultant. Okay, and the resultant was 43 Newton, right? Any question? We finished the second question now. Okay, let's move on to question number 3. As I told you, 3 questions about general physics, 1 or 2 questions about thermophysics, 1 or 2 questions about waves, 3 questions about electricity, electrical component, electric charge, logic gates, magnetism, and 1 question about nuclear physics. Question number 3. A power station burns waste materials from the crops to generate what? Electricity. Okay, Now, state and explain whether this process is renewable or non-renewable. What do you think? Is it renewable or non-renewable? Send me, yes, thank you, Muhammad. Send me on the chat. Okay, it's renewable. Why it's renewable? Why it's renewable? Yes, exactly, because the waste, they will never run out. Waste materials never run out. There's always waste material that we don't need them. Never run out. Run out. Okay? Yes, exactly. Okay, next, part B. The power station used some of the waste thermal energy to heat water, okay, for houses in neighborhood town. State one problem, okay, of using waste energy in this way for the power station is far from the town. Okay, when it's far from the town, what's the problem here? When it's far, what's the problem? Exactly, it will cool down during the distance. Exactly. Okay, that means, okay, thermal energy will be lost. Thermal energy will be lost during the distance. Okay, during far distance. Okay, next. Suggest a way to reduce this problem. How we can reduce the energy lost? We reduce the amount. Exactly. Okay, cover the pipes with what? With insulator. With insulator. Or use pipes with what? Not good conductor. Insulators. Okay. Do not use electricity. Why do not use electricity? The question asks about something else. You have to be careful here. They ask about the power station here. Okay. It used the thermal energy that come out, the waste thermal energy to heat water, to heat the water, okay, to the houses for the neighborhood. Okay, suggest why we can reduce this problem that you suggested that, okay. Paint it white, okay, now I'm not talking about absorbing energy here, okay, or reflecting energy. I'm talking about some pipes, that these pipes, okay, they are already have the hot water. So these pipes, if I put them below the ground, I already insulate them, okay? Reduced rust, no, it's not that big problem. Okay, fine. Next. Okay, state 2, environmental what? Environmental consequences, okay, of burning coal, okay, to generate electricity. Now we know that coal, okay, it has what? Greenhouse gases, right? Greenhouse, what? Greenhouse gases, okay? And also we know that, okay, it's not renewable, not what? Renewable energy resource. Okay. Tamam. Any other questions? Okay, let's move on to question number 4. Okay. In terms of momentum, okay, of the molecules, explain how gas exerts pressure. Okay. You can mention in part C about environmental problem that it causes pollution. Okay. It causes greenhouse effect. Okay. It may be damage the mining, okay, the mining, okay, or drilling the valid of the environmental consequence of transporting coal, okay. All these are, you can write them down as what damages the environment, okay. Any other questions? Let's go back to question 4. Okay, question 4. In terms of momentum of molecules, explain how gas exerts a pressure on the walls of the container. Now, what do we know? We know that gas molecules, they keep moving and vibrating randomly, okay? And they what hit to the walls, okay? And as they hit to the walls, they what hit and bounce, they cause change in what? In momentum. So when they cause change in momentum, okay, that as they hit and bounce, they change the momentum, they cause an impulse on the force. And since we are talking about many air molecules, okay, many gas molecules, that means we are talking about a huge force on a certain area. And we know that pressure equals force over area. So how these exert a pressure on the walls? By this process, okay? Gas molecules keep moving and hitting the walls and bounce back, and change their momentum, causing impulse and force on its area due to the large number of molecules and pressure is force per unit area. Okay? Okay. Yes, thank you, Marwan. Yes. Now they didn't say that the volume expands, so they don't push the walls away. They didn't mention the expansion here. Okay. Part B. A fixed mass of gas, okay, of volume V1 and pressure P1 is compressed to make the volume what? V2. I complete the equation for the final pressure P2 of the gas when the gas is compressed at constant pressure, temperature. What's the formula for this? When they say that there's constant temperature and they mention pressure first situation and volume, then they change the pressure or the volume, that means the formula is exactly P1 V1 is equal to P2 V2. Now I want P2 by itself, so which is equal to P1 V1 divided by what? Divided by V2, and that's how we can get the 2 marks. Okay? Again, so here the formula P1 V1 equal P2 V2 when there is change in the pressure with the volume at constant what? Temperature. The temperature remains constant. Double I, what do they ask? In double I, they say that state and explain how the final pressure compared to P2, okay, when the temperature of the gas increased during compression. So I'm not only compressing it, I'm also giving it heat, so give it energy. What's happening here? As I give it energy, that means the molecules will gain more kinetic energy to move faster. And as they move faster, that means they collide more often with harder force. So that means what will happen to the pressure? It will be greater pressure. Why? Why greater pressure? More energy, which is kinetic energy, to move what? To move faster and collide more often, to move faster and collide more often with a greater force. one of the answers, okay, as molecules move faster, they gain more momentum, so more impulse on the walls. Yes, thank you, Muhammad. Correct answer. Correct answer. Let's move on to question number 5. Here in question number 5, first part, state, that means you know the answer. State the name of the reflection of sound or ultrasound. What's the name of reflection of sound and ultrasound? Thank you, Muhammad. Another answer. Your answer is correct, Muhammad. Another correct answer. A third correct answer. Fourth correct answer. Marwan, it's not like this. When we talk about reflection of sound, we are talking about what? We are talking about echo. Yes, the echo. When we make the sound reflect, we hear it again. That's called what? Echo. So the reflection of sound called what? Echo. It has a specific name for it. It's called echo. Okay. Part B. The figure shows an ultrasound wave being used to scan, okay, an internal organ of the body. This is the shoulder, this is the chest. Maybe they are looking to the heart or something like this. Okay, they have transducer to send and transmit it and receive the ultrasound. Okay, and these ultrasound are sent and go back. What they ask here: the ultrasound wave of frequency 2 megahertz. What do I mean by mega? What do I mean by mega? Send me on the chat. Yes, times 10 to the power of 6 millions. Bravo. Okay, so 2 millions. Okay, and passes through a human tissue with a speed of what? 1,500 meters per second. So calculate the wavelength of this ultrasound. Now we know that V equal F lambda. They ask about the wavelength. So that means wavelength equals speed divided by frequency, which is 1,500 over what? 2 times 10 to the power of 6. And by using the calculator, the answer, it will be 7.5 times 10 to the power of -4 what? Meters. Yes, thank you, Muhammad. Thank you, Marwan. Is it clear? Yes, you have to know how to write the formula in correct way. It's not wavelength equal frequency over speed. No, this is not correct. Okay, you have to be careful. Okay, good. Part C of this question, what do they ask? The figure shows crest of a wave from a point source S approaching the straight barrier. Okay, this is the source and this were the waves. Okay, on the figure, indicate and label one wavelength. This is one wavelength from wavefront to another wavefront. This is one wavelength. Yes, between the wavefront to the next wavefront. Yes. On the figure, draw 3 crests, okay, of the wave reflected from the barrier. They didn't mention the wave that now reach from here, so I have to draw them like this. They ask about any 3 waves, but they have to be what? The same distance. So what I will do, I will use my ruler first, okay? I will use my ruler first to find where's the image, okay, of this source. Then, okay, I will what? I'll draw where's the object here. For example, this is my ruler. Okay, I'll put it here. I'll measure the distance. Okay, from where the surface is reflecting. Okay, like this. For example, at 9 centimeter, it is 1, 2, 3, 4, 5, 6.5 from my ruler. Okay, so again. Okay, from the point where is the reflection, 1.1, 2, 3, 4, 5, and 5.8. I'll do the same thing, 1, 2, 3, 4, 5, 5.8, somewhere like this. This is my image somewhere here. Okay, then what I will do, yes, I'll bring my what? Compass and try to put the needle here, okay, and rotate it until what? I reach, for example, one of these wavefronts, for example, this one. Okay, it's not necessarily to write it down. Okay, then what? I'm drawing this wave. Okay, this is the first wave. Okay, then what? I will open it with the same wavelength. Okay, this is what? The second wavelength. Okay, hold on, it's not correct. Let me make it smaller a little bit. Okay, then I'll what? Open it to make the third wavelength. These three crests, they have the same distance as the wavelength that I drew it. Yes, it's not necessary to draw it bigger, yes, but we have to draw it like this. Will they actually bring it a scale to measure? Yes, they will. By eye, they will see are they have the same wavelength or not. Same wavelength as this one. And for example, the wavelength from here to here, how much it is. So it's supposed to be the same wavelength from here to here. From the okay, by eye, they will not bring a ruler to. By eye, they're supposed to be equal. Okay. Any question? Is it easy? Can you draw it? Can you find the position where is the image of this source? This is the image, the point. Okay, good. Yes, next. Question number 6. Also, it needs what? Drawing. Okay. What do they ask here in this question? Sir, how they will check it? No, they will not check it by ruler. They will check it by eye. Okay. Right. What do they ask here? The figure of a full scale, okay, drawn, okay, showing a converging lens with two principal foci, okay, focus F1 and F2 like this, okay. On the figure, okay, draw two rays, okay, from point O, okay, of the object to determine the position of the image. Label the image IJ, okay. Measure the length of the image. Now we know that this object is between the lens and the focus point. That means it's magnifying glass, right? It's magnifying glass. And I know that to draw this, okay, I need to draw at least two what? Rays. One ray pass through the center of the lens, okay? And it's supposed to be straight line, continue behind, because I know that it will be magnifying glass, so the rays do not meet in front of the lens, behind the lens, on the same side of the object. This is the first ray. The second ray, parallel to the principal axis, okay? And as it reaches the principal axis, it will what? It will be passing through what? I'm sorry. It will pass through what? The focus point, like this. Now, we know also that these rays do not meet, so I will extend this ray behind, and I'll see where these two rays, they meet. I'll label this what? This is the object, okay, by letter I and by letter J, as they told us to draw it with letter I and J. Then I will bring my ruler and measure its length, and it will be 3 centimeters. Don't forget to put arrows, okay, to show the direction of the rays. And these rays do not meet, they meet behind the image. If they ask about an eye, the eye is supposed to be here to see where the magnifying object is. It is. Okay? Good? Is it clear? Are you sure? Okay. Let's return back here. So the length of the image by using ruler, it will be approximately 3 centimeter. Next, any question? Hold on. Okay. Next, part B, rank 3 descriptions of the image. Now, who can tell me what are the description of this image? It will be, yes, it will be same way up as the object. Tamam. It will be upside down compared to the object. No, it will be virtual, and exactly it will be what? Magnified. Yes, thank you. Same way as the object, and it will be magnified. It will be virtual. Yes, all Sandy, Muhammad, Marwan, Muhammad, and all of you are correct. Okay, I have many answers. Yes, three answers, 3 marks. Okay, let's move on to next question. And next question, what do they ask here? They ask about the same thing here, about prisms and refraction of light. Okay, the figure shows 3 rays of green light passing through a glass block. Okay, these are 3 green lines, and these prism, transparent glass block prism. Okay, 3 rays of light approaching the glass block. Okay, on the same path as these green lines on the same figure. Okay, draw the path of these red lights that pass. Now, which one deviates or refracts more, Messi or Cristiano Ronaldo? Cristiano Ronaldo deviates more or Messi? Let me remind you, if I have a prism and there is a white light come like this will be Messi. It will deviate more than whom? Than Cristiano Ronaldo. Okay, it will deviate less. So yes, Messi, because he's shorter, he can change his direction quickly. So the same thing here, I will draw it a little change. Okay, then I will draw it like this. And this same thing, I'll draw it with a little change here. Okay, a little curve. Okay, bending, sorry. Then it will go like this. And the third one, I will show them that it will be in the same line. So this will be my drawing. Okay, if I want to draw it on the scale, okay, it will be like this. Let me show you how I'm going to draw it into scale. Okay. Yes. It will be like this. This is red light, okay, from here to here. Okay, then from here to here, like this. The same one is like this here, okay. Then from here to here. Okay, and the third one from here to here, like this. Okay, and don't forget to put arrows. Good. Any question? Okay. So it should be slightly above it. Yes, a little bit, and farther. Yes. Okay, it will be a little bit farther, like this. Okay, this one here, curve, then okay, like this, and like this. Okay. Okay. Next question. Till now, there is no thermal questions. How? They ask here about thermal, this thermal question. And also, this is thermal question here, this one. Okay, about insulation, this part. Okay, this is a whole question about thermophysics. Yeah, P1, V1, it's thermophysics, yes. And in terms of momentum, how the pressure change, how they cause the pressure, yes, it's momentum. It's thermophysics. Okay, let's move on to question number 7. That talks about magnetism. It's obvious. Okay, what they have. Figure shows horizontal conducting wire XY between two opposite magnetic poles. Okay, wire X and Y. Okay, okay, where forms a circuit with what? An ammeter. Okay, we have this wire and connect to an ammeter. Explain why the reading of the ammeter is 0 while it's not moving. Yes, who can tell us why the ammeter is 0 while it's not moving? Exactly, there is no cutting. Yes, no, there is no cutting of the magnetic field lines. Exactly. Excellent. شكرا يا محمد. شكرا يا مروان. Okay. Part B. The wire XY is moved and there's a deflection on the ammeter, okay? And the deflection of the ammeter that indicate there is a current in the wire from X to Y. On the table, tick one box to indicate the direction of the movement of the wire, okay? XY, and explain your answer. Now the current, they say that it's supposed to move from X to Y. This, I talk about electromagnetic induction here. So I'm going to use Fleming's right or Fleming's left hand rule? Huh? Right or left? Send me on the chat. Fleming's right hand rule or left hand rule to indicate the direction of the motion? Okay, we are talking about right hand rule, not left, because left hand rule, I'm talking about force. There is a current, make a force, make movement. Now here, I will move it to make a current. So I'm going to use Fleming's right hand rule. The first finger is about the magnetic field from north to south. The first finger from north to south. The second finger now, X is closer to me and Y is far. That means into the page. Where's my thumb? It's upwards. So that means, okay, if I want to answer this question, it will be where? To the top, into, where is it? Okay, to the top of the page, to the top of the page, this one. Why? By using Fleming's right hand rule. Okay, by using Fleming's right hand rule. Okay, the first finger in the same direction as. Okay, one of the questions, do I position my hand in the same way? Okay, that every time, or the question change? No, the question change. So you can rotate the paper or rotate your hand. Yes. Do I put upside down? Yes. If you want to rotate it, the whole page, rotate it, but keep your hand like this. Okay, not like this. Some students, they do like this. No, it's in the opposite, like this. Okay. The first finger in the same direction as the magnetic field and the second finger to the current at 90 degrees. Okay, the thumb shows the motion, the direction of motion. Okay, I will explain it again. Let's return back to the picture. Okay, I will explain it again. Now, first finger is field, first field from north to south. Now, I know that my camera is reversed upside, right, left. Okay, so from north to south, this is the direction of the, from north to south, this is the direction of the first finger. Okay, this is the first finger. The second finger, it's into the page like this. This is the first finger, this is the second finger. My thumb, it will be where? My thumb, it will be upward. This is my hand. My thumb, it will be upward if I do like this. Okay? Good, Laith? Do you understand it? So my thumb show me the direction of the motion. Okay? Okay, good. Okay. You are welcome. Then what they ask? Direction of the magnetic field. Okay. Next. State what is observed on the ammeter when the wire XY is moved. What's it's seen? Okay. State what observed on the ammeter. Yes, exactly. Another answer. Exactly, there will be a deflection in the opposite direction. It deflects in the opposite direction. Opposite direction. Okay, in the same direction, but with a greater speed, it will deflect more. More deflection. More deflection. Okay, higher current. Yes, you can say higher current or greater current. Yes. Next question, question number 8. What they ask about electricity. Define electromotive force, EMF. Electromotive force, as the definition about voltage, is the amount of energy given from the supply or the battery for each one coulomb of charge to pass through the whole what circuit. Exactly, the amount of energy given by the supply for each one coulomb charge to pass through the circuit. To pass through the circuit. Good. That's part A. Part B, what do they ask? The figure 8.1 shows a source E, okay, of EMF 60 volt. So we have 60 volt here, okay? And it's connected in series. Two of these meters, they are resistors, they are connected in parallel, but in the circuit in series, okay, with a heater H, okay? The heater H, okay, has a resistance of 22.5, okay, and the potential difference across it is what? 45 volt. So if they are connected in series with these two, and the main source is 60 volt, and this is 45 volts. So how much the voltage for these two together? Yes, how much the voltage for these two together, since they are connected in series with the heater? Exactly, 15 volt. Why? Because 15 plus 45 is 60. Okay, now what do they ask? Calculate the power of the heater. Now we know that the power of the heater is what? Yes, P equal IV. Okay, but I don't know I know the voltage and I know the what exactly. So it's V square over R. V square, which is 45 square, divided by the resistance, which is 22.5. And by using the calculator, yes, thank you, Muhammad, it will be 90 watt. Okay, I know the voltage, but I don't know how much the current, so I use this formula, V square over R. Okay, next. The potential difference across the resistor, what? X. How much the potential difference across the resistor X? It's what? It's 15 volts. How do I know that? We know that the EMF, okay, equal the voltage of the heater plus the voltage in what? In the parallel circuit, okay? That means 60 equal 45 plus the voltage of X, which is 15 volt. Yes, because they are in parallel, so they have same voltage. That's why I write VP, parallel. Then they ask the current in what? In the 10 ohm resistor. Like how much is the current in the 10 ohm resistor? Now we know that V equal what? IR. So V, which is 15, equal I, okay, multiplied by the resistance of it, which is 10. So divide by 10, the current will be 1.5 ampere. Very easy 8 marks question about electricity and circuits. Very easy question. Let's move on. Any questions so far here? Is it clear? Okay, let's move on. Question number 9. What do they ask? Write down the truth table for OR gate. Now we have in OR gate, how many inputs? How many inputs do we have? 2 inputs, okay, A and B. And how many output? Okay, one what? One output. Let's call it C, okay? So we know that in the truth table here, we have to be organized 0, 0, 0, 1, 1, 0, 1, 1. Now, who can remind me for OR gate, when the output is high? For OR gate, when the output is high? Yes, when one or both inputs are high. So this is 0, 1, 1, 1. This is 2 easy marks. Draw the symbol for NOR gate. Now, we know that the NOR gate is similar to the OR gate. This is the OR gate, okay, like this. But it has a circle, and we have 2 inputs. Okay, let's call them A and B, and 1 output. Let's call it C. Okay, this is small circle. Yes. Okay. Part C, what do they ask here? The figure shows a digital what? Circuit, okay? Part C, the circuit shows a digital what? Circuit, okay? Is designed to produce values shown in the table, okay? 9.1. Output from S, okay? So, and from the 2 inputs P and Q, we have a NOT gate here that reverses the signal, okay? And we have gate X, okay? So in the table, okay, the truth table for the circuit, okay, complete the column, okay, R. Now R, as you can see, is the opposite of what? Of the Q, because we have what? NOT gate. So we will go to Q and we write exactly the opposite. 0, it will be 1, 1, it will be 0, 1, it will be 0, it will be 1, then 1, it will be 0, like this, exactly. 1, 0, 1, 0, yes. Now, state which type of gates is used to gate X. Explain your answer. Now, what do we have here? S, okay, is the output for P and R. P and R. Now, if we look to the results of S, 0, 1, it's 0. 0, 0, it's 0. 1 and 1, it's 1. 1 and 0, it's 0. So the answer is AND gate. Exactly. Why AND gate? Why AND gate? Only, bravo, bravo, thank you. Only when both inputs, P and R are high, the output S is high. Excellent, 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 excellent. Bravo. Thank you. No, not necessary to mention the letters, but I don't know the mark scheme. I have to write down what exactly do I need to write down the answer to get the marks, okay? So it's better to write what do you mean by the inputs and what do you mean by the outputs? Because you are explaining. Yes, you are explaining. You have to write all the details. Okay, next. Last question, I think. It's question about nuclear physics. What they ask. State the proton number, nuclear number, and the value of the charge of alpha particle. How much is the proton number? Send me in the chat. How much is the proton number for alpha? Thank you, Muhammad. Another answer. Thank you, Sandy. Marwan, it's a proton number for alpha. Okay, it's yes, thank you, Laith. It's two protons. How much the nuclear number? We know that alpha, it's 2, 4. Yes, so the answer is 4 here. And what's the charge for it? What's the charge for it is positive what? Positive 2 or positive, okay? Yeah, positive 2 is better because I don't know the mark scheme. It's positive 2, yes. This is for the first part of discussion, part A. Part B. A nucleus of strontium, okay, 90 consists of 38 protons and 52 neutrons. Strontium-90 is radioactive that decays beta emission, okay, to be an isotope of yttrium, okay. The symbol of strontium is SR, and the symbol of yttrium is Y, okay. Write down the nuclear equation for this. Now we know that SR, it will be 90, and here it will be 38. Now it emits beta, which is negative 1 and 0, and becomes what? Y, okay. Now this Y, okay, who can tell me what will be the values here of it? Because the nuclear number is 0 for beta, that means how much exactly? Same nuclear number, 90, and how much the proton number? Exactly, it will be, I will add only 1, which is what? 39. I will add only 1, which is what? 39. So 39 plus minus 1 will be 38. 3 easy marks. Okay. Part C. Look here to discussion. The half-life of radon 220 is 56 seconds. A sample of radon contains in a container. After 112 seconds, the mass of the radon is 9.2 milligram. Calculate the mass of the original sample. Now, we know that the mass here in milligrams, the time here, okay, in what seconds? The time was 0, then we keep adding half-life, 56, okay, and another 56, it will be 112. Here it was 9.2. I'll multiply by 2, exactly, I'll multiply by 2 in the past, exactly, so that means it will be 18.4. I'll multiply by 2 again, it will be how much? Exactly, it will be 36.8. So my mass, it will be 36.8 milligrams, or you can say 37 milligrams, because we are talking about 2 significant figures. Okay, good. And that's it. We finished this whole year, okay? If you have any question, you can stay online. If you don't have a question, you can leave. Assalamu alaikum wa rahmatullahi wa barakatuh.